Hello, my name is Herbert Preuten. I'm a digital design implementation engineer working in the SoC implementation team at GlobalFoundries, and currently our team is working on 22FDX reference flow development. The GlobalFoundries 22FDX technology is a fully depleted silicon on insulator technology using planar transistors, and we are using the biasing to tune design performance and design power. That's one of the key features of this technology. The body biasing brings new challenges to the design implementation area. The design team needs to take care of the different cell libraries. They need to define them in the UPF IEEE 1801-2009 file to be able to have proper connections in the design and to place the cells correctly. In addition to that, with applying bias voltage and bias routing in that technology, it's required to apply high voltage rules to the bias network to protect the bias network and the adjacent cell routing. Some of the implementation challenges comes into the game when you use multiple bias voltage on the same design. That means if you are going to time a design at different bias voltages, with this approach you increase the number of design sign-off corners, and that is adding additional effort and time to the implementation. But you get a return for this additional effort because you can tune power and performance of your design. And this is the great benefit, and that's the reason why you're doing this technology. We are pretty much in a bulk-like technology flow or place and route flows. There are not too much differences. We're using the Genus, Innovus. They are well known, and also for extraction we use Quantus, and for the SDA we use Tempus. In addition, we use Conformal for doing low power verification to be able to check the respective voltage domains and where the cells belong to which bias domains. There are only small additions you have to be aware of. That means you have to do a multi-bias domain synthesis. That means you do multi-corner, multi-mode synthesis, and in the Innovus flow you need to do bias routing. So that's the important thing in that technology. If you want to implement a bias net, you need to do the bias net routing. So this is one of the challenges, but with the reference flow GlobalFoundries has put together, we are showcasing that in our design example, and for the customer it's really then just repeating what we have done in our design example. From this project we have demonstrated in the reference flow example that when you time a design at different bias voltages, you can see immediately in the place and route tool and in the power reporting the results. So applying the different bias voltages to a forward back bias technology, you can see how you can play with the design power and performance. And that's same for the RBB technology. When you play with the bias voltage, you can reduce the design leakage significantly. We got great support from Cadence enabling the 22FDX technology with the Cadence place and route tools. We had close collaboration, and we are now able to show that we can handle a multi-bias domain implementation, doing bias routing, playing with the cell performance, and that is showcased in our reference flow that can be downloaded from GlobalFoundries GlobalFoundry View portal for our customers.